Recording. We are going to talk about shifting, reflecting, and stretching graphs. At the end of this lesson, we will be able to recognize graphs of parent functions. We will be able to use vertical and horizontal shifts and reflections to graph functions. And we will use non-rigid transformations, as in stretch and shrink, to graph functions. So, first of all, I am going to, these are the parent functions that we have to work with. I want you to talk amongst yourselves, to your partner at your table. Connor, talk with Kane and Callie. They can be part of your group too. What are these functions? Identify them. Give me an equation. Give me a name. Give me an example. I don't care what. I want you to try and identify what these functions are. Kelly. It is a function because it passes the. There you go. Okay, how about that one? What kind of function do you think this is? It is an even function, yes. Maybe I wasn't specific enough to the class. So, this is an even function. This is a function because it passes the vertical line test. But let me give you an example of what I mean. So, this function right here, the parent function, and I heard linear, excellent answer. But the mom and dad of all linear functions is this. F of x equals x. That is the parent function of all linear functions. What do I mean by that? What I mean by that is, if I gave you any general line, like say I gave you f of x equals 1/2 x plus 3. Okay, let's say the slope was 1/2 and that was 3. Right? What I'm telling you is that I can take this function, multiply it by something, multiply it by 1/2, makes the slope flatter, right? And I can add something to it. I add 3 to it, and I get that. So I can take a parent function, manipulate it, and turn it into anything I want. All right? This one right here, this is the parent function for all quadratics. F of x equals x squared. And what I'm telling you is that any parabola that you see, I can move it up or down, left or right, flip it, make it skinnier or fatter, starting with this function. That's what I mean by a parent function. It is the simplest form of all parabolas. Okay? So if this is a linear, that's a quadratic, what do you think this is? Follow the pattern. Oh, I heard it. Cubic. That's a cubic. F of x equals x cubed. That is the mother and father of all cubic functions. Very good. If I go down here, now I got some funky ones. This is f of x equals c, where c is just some constant, right? And so, regardless of what x is, the function is always going to equal that constant. What do you think this guy is? What do you think, Zach? F of x equals what? Does that give anybody? Oh! Keely's brain just exploded. There you go. There you go. The absolute value of x. There you go. That was fun just to watch your head spin like that. And we call this the absolute value. You know the Brits? The Brits call this distance. And I actually like that name better. And in about 2 months, you're going to find out why I like distance better. But, anyhow, last but not least, this guy. What's that guy? I feel like playing hangman here. There you go, square root of x. Okay. Okay. This is our library of parent functions. So just about any equation or any function that we see, I can play around with these guys and make that equation. Okay? Let's go. On your Google Classroom, I attached this web link, okay, which is the catalog of parent functions. So you can go to Google Classroom and pull this up at any time. But let's talk about vertical and horizontal shifts. All right? In order to do this, I need to sit behind my computer, which means that when Keely watches this tonight, she's going to see she's going to hear me very well, as opposed to normally. All right, so check this out. We're going to go to Desmos, and I'm going to start graphing, except I need to, it's already logged in as me. All right, so we're going to talk transformations. All right, now, except I don't want that one. Do I? I'm going to do a new graph. So f of x equals x squared, x squared plus a. Actually, I'm going to do c. All right, now, look what happens when c equals 0. I could just simplify that equation to y equals f of x, can I not? Oh, I'm sorry. When c equals 0, let me be more specific. When c equals 0, I can simplify that function into f of x equals x squared. Can I not? Yeah, okay.
But look what happens to my graph when I manipulate C. When I increase C in value, what happens to my curve? It just moves up, right? And when I decrease it, it moves down. And if I hit the play button, it's jump roping very slowly. So I'm going to speed it up, and we see how that works, right? Now we got Rocky exercise montage. Okay? So how do I move things vertically? I just add or subtract something to the end of the function, right? How do you think I do? That's very distracting. How do you think I move stuff from left to right? Talk amongst yourselves. We'll give you a couple minutes here. Talk to each other and see about how you think you could move this thing from left to right. How do you want to talk with Liv and Zoe? How can I move it from left to right?
That's just the how drastic the change is.
Let's talk about how to move this guy. But yes, we'll make that happen, okay? Anybody got a theory or a proposition? Connor's brave. Ooh. So y squared plus c. So you're basically saying, instead of squaring x, I'm going to square y. Huh. Let's see. I'm going to do a new one. After y equals y squared plus c. So what happens when I'm at y squared, I got a sideways parabola now, right? Well, it's funny you say that. If this was a function with respect to x, if this was f of x, would it be a function? No, but is it a function with respect to x? It's a function with respect to y, right? So for any value of y, do I get more than one value of my function? No. So is this a function? Yeah, so do you see where simple tests like the vertical line test can fail us? Okay, that's why we need the importance of knowing the definition of a function. All right, good guess, Connor. I am proud of you. Any other propositions? Plausible or otherwise? Check this out. All right, so when I increase my b value, let's say I make b equal to 1. What do you think is going to happen? It's going to shift to the right. Who says it's going to shift to the right? Who says it's going to shift to the left? Who says it's going to move up? Down? All right. So everybody says it's going to shift to the right. When I increase this to 1, it goes
It goes to the left. Whoa!
What is this?
Whoa, what's that? Think about this though. Okay, when x equals -1, what is x plus 1? Go ahead, say that nice and loud, Zach.
0.
0, right? So when x equals -1, it's going to be the stuff inside the parentheses, the stuff that I'm squaring becomes 0, right? So it's actually going to move to the left. It's going to do the opposite of what your intuition tells you. Okay? And it's great that everybody made that mistake, because everybody makes that mistake. Isaac Newton made that mistake. Granted, he made that mistake when he was like 6, but the guy's a genius, so we'll cut him some slack, right? But look at that. And when it's negative, when my b value is negative, it actually goes to the right. Okay? So really, what we do when we write this is I subtract it. Now, it follows my intuition. When b is positive, it moves to the right. When b is negative, it moves to the left. And I did that by changing the negative, or the subtraction sign. I changed it from plus to minus. So then it follows our intuition. So this is the form you will see. And then the last thing. So this is how I change my vertical and horizontal position of this graph. Does that make sense to everybody? All right. So let's go back to this. So f of x equals x squared. This is my parent function. Okay? But I can also elaborate. F of x equals x minus b quantity squared plus c. C greater than 0, graph goes up. C is less than 0, graph goes down. If b is greater than 0, if b is greater than 0, then I am subtracting a positive number. It goes to the right. If b is less than 0, I am subtracting a negative number, which means I'm adding a positive number, which means it goes left. Okay? So, this is going to fool everyone in this class at least once. When I give you the function f of x equals x plus 3 with the parentheses squared. And I ask you, what is the transformation that happens to the parent function? What am I doing to x squared? Everybody's going to do this at least once. You're going to say it's going up 3 and it's going to the right 3. Everybody's going to do that. Right? What is it going to the right? It's going to the left, because this is really x minus a negative 3 squared plus 3. Do you feel me? Everybody's going to make this mistake. Everybody's going to make this mistake. I promise you. Don't get down on yourself because you make this mistake, because everybody makes it. At least once. Okay, we covered horizontal shifts. Now, I have done this not just for, this is not true just for quadratics. This is true for everything. Okay? This is true for all functions. So, if I want to shift this up,
If I want to shift any function up, whether it's a linear, whether it's a quadratic, a cubic, a quartic, we haven't gone over quartic, but quartic, power 4, a trig function, an exponential function, I add some constant to the end of the function, okay? So I get a new function, I'm calling it h, by taking my parent function and adding a constant, a positive constant to it, okay? Because it says up here, let c be a positive real number. If I want it to go downward, I subtract that c value. And then, horizontal shift to the right, I subtract that c value, and then apply the function f to it. If I want to shift it to the left, I add that c value, and then apply that new value to f. Right? So I'm taking x, I'm adding c, and then I do f to it.
Sounds dirty. I'll give you a couple minutes to write that down.
It is a good idea to get well versed in writing like this so that you can think like this and understand this when you read this.
How are we looking on that?
Good to go? You ready to go live? All the rest of you are finished now. Notice how I put that. Y equals f of x. Why do I write y equals f of x? Where do I draw all my functions? Do I draw my functions on dirty napkins? Where do I draw my functions? On the graph, which we call the Cartesian plane, but we used to call it the coordinate plane or the XY coordinate plane, right? So basically what this tells me is, hey, my f of x is just representing the y coordinate on that XY plane. Okay? Ready to go? Let's take that as a yes. Reflecting graphs. I'm going to draw the f of x equals x squared. Okay? Alright, there you go. We'll call that f of x equals x squared. How do I flip that? How do I reflect it upside down? Make it negative. So, let's with C. So if I said h of x equals negative x squared, that would do that. So to flip it or reflect it about the x-axis, I just multiply it by a -1, and that flips it. Okay? Okay? Now, stretches and straights. Let's look at the function f of x equals absolute value of x. I'll do that in the red. And again, forgive my crummy artwork. Now, why be like this, right? How would I make that skinnier? How would I make it like that? Not straight up, but like a D, but skinnier. So Connor says subtract the value for x from x. So I'll make my h of x equal to f of x minus some positive real value like that. So that would equal the absolute value of x minus c, like so. What did we say this would do though? If I apply the function after subtracting a value, Sam, what do we say it would do? You're right there. You're right there. It shifted which way? Up, down, left, right. Close. You got the right dimension, but the wrong direction. It'll actually shift it right. It'll actually shift it to the right. Shift it to the right. Okay, so it's not this. What is it though? Let's go back to Desmos, because Desmos is awesome. Let's go back to Desmos. Now I'm going to make this one disappear. I'm going to do a new function. I'm going to call this h of x equals the absolute value of x. All right? And I am going to multiply by a. That's a equals 1. What do you think will happen if I increase the value of a? So Caleb says it's going to make it flatter. Who agrees with that? That's the intuition. Who says it's going to do the opposite, make it skinnier? Who doesn't know? Who doesn't care? Your brother is the same way. Same way. All right, let's see what happens when I increase A. Oh, look at that. Look at that. Again, our intuition tricks us. Think about this, though. I'm set this back to 1. When A is 1, right? This thing takes whatever x is and just makes it the positive value of that x, right? Now, when I increase A, let's say I increase it to 2. And when x is 10, right? It takes that 10, makes it positive. If it's negative, it makes it positive. If it's positive, it just keeps it positive, and then multiplies it by 2. So now, what used to be 10 is now 20. And what used to be 20 is now 40. So you see how it makes it skinnier. We call that a vertical stretch. Or we also call it a horizontal shrink. But
what I like doing is keeping it in the vertical plane, meaning I'm just concerned about what it does to this vertically. If I get into if I worry about vertical and horizontal, because think about this, I could call this a vertical stretch. Could I also call it a horizontal shrink? Because I'm crunching it in the horizontal direction as well, right? But let's just focus on the vertical, what it's doing to this graph vertically. So it's stretching it vertically. Okay? Now what happens when this thing, let's go back to 1. What happens if it's less than 1? Zach says it flattens out. Now that we know what happens with greater than 1, who agrees with Zach's intuition? Nobody's with you, Zach. You're all on your own. Oh, we got one convert here. One convert. Let's see what happens. We're going to go down and look at that. It gets flatter. Now what happens when it's 0? It's perfectly flat on the x-axis. Yep. What happens when it's negative? What did we say negatives did to our graph? Remember, negatives, if this A is negative, it reflects it about the x-axis, does it not? And the bigger that A gets in the negative direction, the more vertical stretch I see. Until it's like a steeple at that point. Okay? So do we see what that A value does? So let's put that A value in our quadratic. Oh, not there. There. And turn it on. And then play it. And see, it does the same thing with our quadratic as it did with our absolute value function. Does the same thing. And if I move my B while I'm doing it, and if I change my C at the same time, and then I got something really freaky, right? Fun with Desmos. All right. So I can make any parabola, any absolute value function, any line I want to by playing with this A value, this B value, and this C value. Okay? So back to this. We combine those transformations, right? And we saw what we got rid of. Here. There it goes. Alright. And then, I had the website up here, but it's on your Google Classroom. It's not there, but it's on your Google Classroom. So, I'm done with that lesson. That lesson is done. So, for homework, this will be due on Friday, let's say. Oh, that's right. Tuesday. It's Thursday. We haven't had homework in a while. So, for homework, problem or the practice set rather. Section 1.4 practice set. This is on page 48, due Thursday. We will make Thursday a work day as well. Okay? And I will have a take-home quiz for you over the weekend. You like take-home quizzes? We like the take-home aspect of our quizzes. Is that a fair accommodation? Okay. Okay. Now, what we're going to do is we're going to do 1, we'll do 1 through 1, 3. You know what? Let's just do 1 through 9 or 1 through 11. 1 through 11. Odd. Okay. We'll do 13. And then, now, on 1 through 11, it has you use a graphing utility, yes? You can use Desmos for that. Or you can use your graphing calculator if you know how to use it. It doesn't say graphing calculator on the book. It says use a graphing utility. Desmos qualifies as that graphing utility. I don't like it when those things break off. All right. So there. And then, 43 through 47. And then, yeah. Okay. I want to do 44 with you guys so you can see what I expect in 43 through 47. Okay? So, for 44, it says g of x equals negative x plus 10 quantity squared plus 5. And it says in the book, in exercises 43 through 56, g is related to one of the 6 parent functions on page 42, right? The constant function, the linear function, the square function, the cubic function, the absolute value function, and the square root function. Those are our 6 parent functions, okay? Identify the parent function f. What is the parent function in this particular case? The squared function, the quadratic, yes. F of x equals x squared. So what we do is, for part A, f of x is our parent function, right? That equals x squared. That's our parent function, okay? And then part B, it says, describe the sequence of transformations from f to g. So what do I have to do to this to eventually get that? So what's the first thing I have to do? So the first thing I have to do is the stuff in the parentheses. I add 10 to x, which does what? Shifts it 10 units to the left. So, shifts 10 units to the left. Okay, then what? MDAS, bro. What's that? What's next? The next thing I'm doing is I'm multiplying by a negative, which reflects it about the x-axis. And then lastly, I am doing what? I'm going up five units. Up. Now, I bring this one up because why? Let's say I shifted 5 units up and then I reflected. So this one here, let's do this.
this one is shifted 10 units to the left. 10 units to the left. So we'll call this 10. Reflects about the x-axis. So this is going something like that. Okay? What if I shifted 5 units up and then reflected? Would it change it? Would it? So I took this guy, right? Let's get that out of there. Okay. So I take my parent function parabola, right? And then I shift it 5 units up, right? Well, first I moved it 10 to the left, right? So somewhere about there. And then I move it 5 units up. And then I flip it. Did it change it? So then this becomes an upside down version. It's the same thing as this, really. It really is. Or is it? What happens if I flip this about the x-axis? Is it going to be? Is it just going to be a hump right there? The hump is actually going to be down here, right? The hump is going to be down. Let's try that again. The hump is going to be down here someplace. So you see the order in which I write this is important, is it not? It's important. So remember that when you're doing your homework. Okay? So, let's see, that's 1, 3, 5, 9, 11, 13, 43, 45, 47. That's 9 problems. Fair? I see Wyatt smiling. He never smiles. At least not in this class. This is like the first smile I've gotten out of him in this class. The second smile. There you go. We fair? All right. And I'll have a quiz that we will be able to do over the weekend. While I'm doing in-service, you guys will be doing the quiz. Yes, yes? Yes, yes. All right. Great.